All right, so we have our regular M&Ms, of which 6 of them are orange. So we're going to be talking about the orange on average with that standard deviation. But then we had those new Halloween M&Ms. There was more orange ones in there. 11.25 are orange. Okay, with the standard deviation of 2.49. So what did you guys say that is happening with our, when we combine means? They are what? What can we do? We can just add and subtract like normal. No special rules with the means. We like that. We like they are intuitive. They do what we expect them to do. Expect them to do. Means are the expected value. Okay. But look here. So let's see. How would we find out how many orange candies you expect there to be in your 3 packages of regular and 2 packages of the Halloween? So I want you to put down what you think that would be. So figure that out on yourself, for yourself right now. Okay, now I feel pretty certain that you probably just thought, oh, 3 times 6 plus 11 times 11.25 times 2. So you probably did this, and that is fine. I get it. Okay, that's what I wanted to do first. But here's the thing, and that's fine. I mean, you can do this and you get your 40.5, and that's fine. But I must, as we learn this, stress to you that you need to think like that this is what is happening, even though we ultimately might shortcut it and write it out like this, okay? And what happened was I put out a thinking map of this stuff on my AP forum, and I got a lot of like teachers saying, well, wait, this is kind of, you need to just make sure that you tell them to think 6 plus 6 plus 6 plus 11.25 plus 11.25. So you are definitely wanting to make sure that you are thinking that there are 3 of these and 2 of those. The reason that that is important to think of it that way is for standard deviation. It's all good, but when standard deviation comes around, that's when it really matters. So we're just going to be consistent in our thinking. Because if I want to combine standard deviations, tell me, can we just add the standard deviations like normal? No, we cannot. So, a couple things. We know we cannot add the standard deviations together. Okay, we cannot add the standard deviations together. We have to do what with them? Go through what I coined as the Pythagorean theorem of statistics, where we added those variances. So we add their standard deviations squared and then took the square root of it. Okay. And then also what we just talked about, remember our serial example where even if I'm subtracting their means, their standard deviations are always adding, even if you're subtracting the means. Okay, so how would that look for this situation? What would be the combined standard deviation of 3 regular and 2 Halloween packages? Okay, we know there's going to be 40.5 orange M&Ms on average, but with what variability? So let's see how that would look. Okay, keep in mind this is what's happening here. The R plus R plus R plus H plus H, see? So then you're going to think of it like this, that you're going to have the regular squared, the regular standard deviation squared, or the regular variance, and then the Halloween variance and the Halloween variance. It is those items that I sum together. Okay? All right, and so you have to think like saying there are 3 of those regular variances plus 2 of those Halloween variances. Now, you could write it like this. There are 3 of the regular variances and 2 of the Halloween package variances, okay? And this is where I got in trouble. This is where I got flack on my AP when I put that thinking map out there. The teachers, called me back on this and said, "Hey, this is where if you are not teaching it to think this way, that we could have some confusion where this comes into play." I originally wanted to start with this right here because guess what? An AP multiple choice question answer was in this format. So it was because I had looked at that multiple choice question that's why I wanted to teach it this way, okay? But more experienced teachers had told me, okay, I get it. You want to write it that way, but make sure students think of it like this, combining those 5 items together. Okay, so that's just the one thing that kind of is a little cumbersome, but it's going to help you out, hopefully, in the long run to make sure you keep those straight. Okay, done with combining several random variables. Let's now talk about and review the transforming. What is that transforming doing to our means and standard deviation? So here we go. We're going to be talking about our good old Lucky Charms cereal and Life cereal again, and how many are sold at a local grocery store on average, okay? Now, before I talk to you about when we transform means, okay, let's talk about this. Read this little section here and talk to me about what this problem is transforming. These units into these units. So read through that and figure out what transformation is happening in this problem. Okay, so odds tell the evens. What do you think is going from what to what? Go. You get to tell me, what do you think?
Is it the number of boxes to price?
Good job. Yep. Okay, so what do you think?
Would it go from the amount of boxes to like the monetary value?
Yep, very good, very good. Okay, so what are we transforming from? So odds to the evens, so the evens tell me. What did you guys come up with, Merritt? Who's even over there? What'd you got? What were you told? Very good, yes. They're telling us things in terms of number of boxes that are sold, okay? So Walmart's keeping track of all these spreadsheets of all the number of those products sold per day on average, and then they, of course, want to know what that profit is, okay? So very good. So what I wanted to make sure, okay, so let's talk about transforming means first. So remember my little picture of remember my little spirograph or whatever this is called? This is my transformation tool. Means, the center. What mathematical computations affect where this center is located? Does addition and subtraction affect the center location? Yes, it does. Add, subtract affects the center. How about multiply and divide? Multiply and divide, is that affecting the center? It is. The center's here, but then if it was like this, the center's here. So it's bigger when I'm multiplying. Okay, so transforming means we know that means measures of center are affected by add, subtract, multiply, and divide. So we're good to go. Okay. So in this case, when we're talking about 65 cents per box, what mathematical function is that? What mathematical function is our 65 cents per box? Multiplication. Thank you. Very good. So what I want you to always do when you have transformations and combinations, you're always going to transform first, then combine. This is going to help you keep things straight in the long run. I want you to transform first and then combine. So I want you to go from the mean of the Lucky Charms to the money for the Lucky Charms, and the mean number of life to the mean money for the life. Do that first. I'll give you a moment to write those in there, knowing we have 65 cents per Lucky Charms, 72 cents per life box. Do that now. Okay, so we put our 65 cents per Lucky Charms boxes and our 72 cents per life boxes. And there's our money. Okay, there's the average money of those. So now I'm going to combine. Am I combining? What can I do for means? What did we say about means combining? They add and subtract and such by like normal. So I can just do my 910 plus my 1296. So I know that Walmart expects, or whatever grocery store local, because I'm sure Walmart would be maybe selling more, I don't know, expects to be making 2206 per day on just these two products. That's their just profit. Okay, profit. And I guarantee you, if you think about it, this is just two products. They have spreadsheets and spreadsheets and spreadsheets analysis. If you go into business analysis, and a new degree that the Walton School of Business is offering is a becoming a business analytics is what it's called. You're doing spreadsheets and spreadsheets and keeping track of all of that stuff. Okay, so now back or to the next page. This is page 17 in your packet. So I know yours got stapled out of order, so scoot back a little bit and find your page 17. So we're going to now transform standard deviation. Before we do that, let's kind of recall that the Lucky Charms was being 65 cents per box, just so we can recall from the previous page. And our life was profiting 72 cents per box. Okay, so that's just remember from the previous page. Okay, so here we go. Here's my transformation tool. Transformation tool right here. What mathematical functions are going to affect my spread? Add and subtract? No, that spread stays the same. Add and subtract. Shifting does not affect spread, but multiply and divide does. Okay, so transforming only standard deviation is only affected by multiply and divide. Okay, so keep that in mind as we go through here. So I want you to transform these boxes standard deviations into money standard deviations. And so you are going to transform first, and then you will combine. So we'll get the combined standard deviation. Okay, do that now. So my Lucky Charms standard deviation is $2.20.275. My life standard deviation money is $3.24. And what must happen when we combine? Can I just combine those, add them together like normal? No, standard deviation, that's special diva. It's got special rules, so I'm going to do what? Pythagorean theorem. So I'm going to combine them. I'm going to do my square root of my money for the variance money for Lucky Charms and the variance money for life. And that comes out to be $3.96 per day, So what this says, that the grocery store is profiting $22.06 on these two products alone with this variability. You see why as a business owner, you're managing and, you're making adjustments and you know how much your daily amounts vary. Okay? Big deal. All right. Last thing of learning is just a transformation that's a little more complex, because transformations are not always just 65 cents per. They're not always just per. Sometimes they will have a constant involved, okay? So here now we have a constant. What do we typically do with just a constant amount? It just gets added or subtracted. No not like 65 cents per box. Okay, so let's look at this. Here's how I tried to come up with a situation. General Mills is the parent company. That is true. It actually is the parent company that that makes the Lucky Charms cereal. Well, guess what? They've contracted with a grocery store that they will give the grocery store a daily bonus of $3 if that cereal is displayed on the end caps of the aisles. What does that mean? Why would they offer a bonus for that? Yes. If it's on the main aisle, everybody goes down the main aisle. Whereas if it's just on the regular in the middle, then not everybody goes in there. So more visualization, better marketing. They think they're going to get sold more boxes. So they're going to offer an incentive to the store to give up that valuable end cap space and put their items there. Okay, so here we go. So $3 bonus for the Lucky Charms if they get on the end cap. And then Quaker Oats is the parent company for life. True story. And they're going to offer $2 a day for life if they display it on the end caps. So what would the transformation functions for these two cereals look like? So what would that transformation function for Lucky Charms look like? And that transformation function for life. Okay, figure out what you think that is. We still have our per box profit. And then what's going to happen with the 3? Yep, it's just a flat added bonus. And of course, we're keeping in mind, what does this X mean? Good. X is representing your number of boxes sold of that type. Good job. Okay, what was our life transformation function? Those ones were 72 cents profit per box. And then what was the bonus on that? $2. Okay. So see, this is a transformation function that has multiplication and addition in it. Okay. So this is going to help us understand how to add those or figure out those ones. Okay. So here we go. Let's see here. I don't know what's going on with that. Okay. So let's read what's happening. We've got this same stuff happening here where we're going to go ahead and do this transform the means, and then transform the standard deviations according to these functions. So do the means first, transform the means, and then combine them through the two products that both get displayed on the end caps, so they have that additional bonus. So the transforming included the multiplication and addition, because remember that the means are affected by both addition, subtraction, multiplication, and division. Okay, curious. Go look back at what you did on the bottom of the previous page and figure out how is this total different from the bottom of the previous page whenever there was no daily bonus. What's the difference? $5 daily. Well, does that make sense? Why? Yep, because there was that component there. So it took all that data and it just shifted it up $5 a day. Okay, because that's kind of what adding and subtracting is doing, is that shift. Now, let's take a look at our transformation for standard deviations, because we know that standard deviations are only affected by the multiplication and division transformation. So figure this out for standard deviation. Figure out the combined standard deviation for this price per box and daily bonus. You want to do your transform first and then combine. What have you noticed? Good. Because should this transformation affect the standard deviation? No, it does not. The +3 and the +2 do not affect the standard deviation. Therefore, this is the same as what we had at the top of the page earlier, where we then just had those numbers. So it's going to be the same as the top where we had no shift. Okay, so it's like taking all of your data. Here's all your data, and it's that wide, and then we just took it and oopsie, I don't want to do all of that. We took all your data. Let's try that one more time. Here we go. Here's all your data. And instead of just being 65 cents and 72 cents per box, we took it and we shifted it up, and that did not change the spread. So the data just shifted up $5, not changing the spread. Okay? Very good. That is all the learning. So now if you'll take a look at your pages that you're going to work on, there's 7 problems, 18, 19A, and 19B, where you're going to do that. You have got 12 minutes, and I want you to definitely get through. I want you to get through numbers 1 and 2. I want to walk around so I can help you. 1 and 2 in class. 1 and 2 in class, so that I can help you and make sure you're good. Because I think number 2 is the hardest out of all these 7 problems. So if I can get you through number 2 and make sure you understand that, then you should be okay on the others. All right, so go ahead and work on that. Okay, so I'm kind of moving you along real quick. You had done your little probability table, and then they did the one variable stats. You did your one variable stats of L1 with L2's frequency. Okay, one variable stats of L1 with L2 frequency, and so then that's how you got this mean and this standard deviation. Combining 3 coin tosses together, you just add those means like normal, but combining 3 standard deviations is special. Okay, now, real quick, this is the toughie, the one I want to make sure that we get through in the next 5 minutes here. So I'm going to give you a few minutes to work, and then I'll come back and talk to you about this. You've got combining of husband and wife amounts, and you have also a whole week's worth of amounts, which is 5 days combined together. So you got combining together happening twice on this problem. So you can think of this in 2 different ways. Here is one way that I've seen most common. Figuring out, okay, the means are fine. The means, you just added them together and all that stuff. And the mean, the combined weekly mean for the husband and the wife for the whole week was $60. Okay, so that was fine because means are normal. They do what we want them to. Problem comes with standard deviation. Because if you want to do the husband for the week's worth of the husband's standard deviations is Monday's standard deviations plus Tuesday's variance plus Wednesday's variance plus Thursday's variance plus Friday's variance. And so you have the entire weekly standard deviation for the husband here. So this is the husband's weekly standard deviation. Similarly for the wife, 5 days worth of wife's variances. Okay, and so the wife's weekly standard deviation is this. So that's the husband and the wife separately. Now combine the weekly husband and wife amounts, variances. So you have that again, standard, the special rule. Okay, so ultimately it comes out 559. All right. Hey, you know what? I know that it's 3:05 or it's time, but one quick thing that I did wrong this morning, I asked somebody about online, and they helped me make sure that I understood that whenever this problem says 2x plus 3, you think of combining 2 x's and 3 y's. So that means, you're going to be adding 2 x standard deviations with 3 y standard deviations and square rooting it. Okay, so there's where I did wrong this morning. All right, so finish that up for homework.